Now we look at example 3. Given the function y exponent power of x minus 1 plus cos 3y is equals to 2 minus x squared. So A, find dy dx using implicit differentiation. B, find the equation of the tangent line to the function at the point 1 and 0. So in this example, it combines both implicit differentiation and equation of tangent line. So you can refer to the previous video for equation of tangent line. So first we look at find dy dx using implicit differentiation. So in this case, in the first term in this expression, y exponent power of x minus 1. So you can see that actually this is the multiplication of two functions. So means that I have to use product rule. Here is our u, exponent power of x minus 1 is our v. So here we should use product rule. So next, differentiate cos, then differentiate 3y. So this one we differentiate as usual. So now we look at question A. So try to solve A. So here is A. This is product rule. So means that in our first part, we should use product rule u v prime plus v u prime. So plus, first differentiate cos, I should have negative sign and then 3y. Next, differentiate 3y, I should have 3, don't forget dy dx. Because we differentiate y, 3y, 3 dy dx is equals to, differentiate constant is 0, differentiate negative x squared will become minus 2x. So now I substitute in this our uv. So let's say I calculate my u is here, or I can calculate here, u is equals to y, v is equals to exponent power of x minus 1. So u prime, differentiate y, we should have 1 dy dx, or we can just write as dy dx. Then v prime, first we differentiate exponent, second we differentiate x minus 1. So first we differentiate exponent, we should have exponent power of x minus 1. Then I differentiate x minus 1, differentiate x, I should get 1, differentiate negative 1, we should get 0. So it means that we will get back exactly the same, exponent power of x minus 1. So next, I will substitute in this expression. So u is y, v prime is exponent power of x minus 1. You can refer to here for uv, u prime, and v prime. So here, let's say I prime. So this is u prime. So plus v is exponent power of x minus 1. U prime is dy dx. So I try to rearrange here. Positive, negative will become negative 3 sine 3y dy dx is equal to negative 2x. So next step, I will put the dy dx together. So means that I will move y exponent x minus 1 to the right hand side. So from here, exponent power of x minus 1 dy dx minus 3 sine 3y dy dx will be equal to negative 2x minus y exponent power of x minus 1. So finally, factorize the dy dx. Here we have exponent power of x minus 1 minus 3 sine 3y is equals to negative 2x minus y exponent power of x minus 1. So finally, I divide this expression to the right hand side. My dy dx will be equals to negative 2x minus y exponent power of x minus 1 over exponent power of x minus 1 minus 3 sine 3y. So this is our dy dx. Next, we move on to question B. Find the equation of the tangent line. So in order to find the equation, if you still remember in our step 1, we will differentiate the function. So since it's in A, we already differentiate the function. So we can skip for step 1. Because we already, we can skip. So we can skip the step 1. Skip. So we can skip for the step 1 because we already found the dy dx. Now we proceed to step 2. Substitute the value of x, which is x is equals to 1, into dy dx. Why? Because we want to find the gradient, or we want to find the slope. Slope is referred to the dy dx. So I can write here, when x is equals to 1. So here is, let's say, here is our x. So when x is equals to 1, my dy dx. So I try to substitute into dy dx is negative. Oh, here is our x and y. So we have to substitute x and y. So here is our y. So when x is equals to 1, y is equals to 0. So my dy dx will become negative 2 times x, x is 1, minus 0, because this is y, times, let's say 0, I put a bracket, times exponent x minus 1. So it's 1 minus 1 over exponent against x minus 1. So it's 1 minus 1 minus 3 sine 3 times y. So y again is 0. So here is 0. So it's equals to negative 2 times 1 is negative 2. Any value multiplied by 0 will become 0 over exponent power of 0 minus 3 sine 3 times 0 is 0. So next, this is negative 2. Exponent power of, So from here, let's say, negative 2 minus 0 is negative 2 over exponent power of 0 is 1. Sine 0 is 0 times 3 is 0. So here we have negative 2, which means that our m is equals to negative 2. Now we come to step 3. Step 3 again is to find the value of y. So since the point is given, so we can skip for step 3. Finally, we come to step 4. In order to find the equation of the tangent line, we are using the formula y is equals to mx plus c. So first we try to find the value of c, where we already have the point, which is 1 and 0, and the gradient is m is equals to negative 2. So I substitute all the value into this formula in order to find the value of c. So where y is equals to 0 is equals to m is negative 2 times x is 1 plus c. So 0 is equals to negative 2 plus c, or c is equals to positive 2. So finally, therefore, the equation of the tangent line will become y is equals to m, where our m is negative 2, so it's negative 2x plus c plus 2. So this is our equation of tangent line. We will repeat the 4 steps in order to find the equation, and this is the implicit differentiation.